All right, so once again, we're on page 100 in the book. We're looking at number 53. This is part of your homework assignment, but again, we're going to do it together as a class so that you can reference it later. In part A, you were asked to draw a diagram that represents the problem. In this problem, we've got a couple pieces to it. Number one, we've got a rectangular part of the room, but then they went ahead and they said that there were two semicircles on each end. So we're going to add this and this. By adding those two pieces, does it not look like a traditional track? Yes? Okay. You were also asked to add some dimensions. So we're going to call X this piece here. And from here to here, we're going to call this the Y piece. Okay. So for part A, you were asked to draw a diagram based on the given information. For part B, they're giving you some leading information. They said determine the radius of the semicircle. So if I look at this picture, I don't know what the actual length of that segment is that runs from one side to the other. That again is not a radius. What do we call that? A diameter. But what is the relationship to the radius from the diameter? It's what? It's half. So the idea here is that the radius is going to equal to 1/2 of the diameter. But then we need to translate that concept to our diagram. Because we don't have the letter D, what do we have? We have Y. So the radius is going to equal what? 1/2 of Y. Okay? That's what's important for part B to start out, that the radius is going to equal 1/2 of Y. The next thing we want is we want a distance. Change colors here. I'm going to figure out, and this is function notation, a distance in terms of Y for the entire running track. So we're trying to find this purple, swoop around here and back around. Okay. Now, did they tell you in the problem what that entire distance was for a lap? Jordan? 200 meters. So we know that this distance is 200. The problem is by writing that statement, there's no input of the Y values. Okay. Now, one of the things that you have to start to envision in these problems, why we would have two variables, is think about the fact that as I decrease Y, doesn't that make X maybe bigger? There's many different shapes that the track can take on, how thin it is or how wide it is. So the key here is that the information that they gave me, specifically this, is going to determine the exact combination of X and Y that we need to answer the question. So if I start here, if I want to find this distance around, it's comprised of a couple pieces. The first piece and the second piece are these. What are the lengths of those? How long are the pieces that run from end to end here and here? No, 200 is the entire lap. What does it say in my drawing is the length from here to here? X, right? So out of that 200, I need to symbolically say, okay, I got that. Out of 200, I know that I have to run X plus X here and here. Plus, I need to run two semicircles. What do we get when we put two semicircles together? Circumference. What's the formula for circumference? Circumference equals geometry. Something with a pi. Close. You're combining with area. It's either 2 pi r or pi r squared. It's 2 pi r. 2 pi r. Okay? 2 pi times the radius. Aha! I know what the radius is. What's the radius? I just wrote it. What's the radius? 1/2 y. So if I take 2 times pi times 1/2 of y. What can I cancel? The 2's. So that gives me just, not 2, but just pi times y, which would be the perimeter of the two semicircles put together, creating the full circle. All right, now, this is where notation becomes important. I want the distance in terms of y. Distance in terms of y. What letters don't belong? The x's, right? I don't want my x's to be there. So what do I do here? I'm working my way through this. Made my diagram, converted the circumference into the variable y. Now I need to talk about x. What does it say in part C to do? What does it say to do in part C? Use the result in part B. So here's part B. Use that result. So here's my result right here. And do what with it? It told you what to do. What does it say to do? In terms of x and y. So don't we have that right here? 200 is equal to x plus pi over y. Where we solve out for what variable? Y. So, how do I do that? Now we're talking about like PEMDAS, solving for variables. Jordan? Okay, combine my 2x's into 2x. So I've got 2x plus pi y. Now what? Bring over the 2x. So 200 minus 2x is equal to pi times y. And what? Divide. Known as pi. You can leave it in symbolic form. So when I'm done with this, I now have an equation that says y is 200 minus 2x, all of which is over pi. Interesting. All right, so recap. We made a drawing. We used circumference in order to transform the y value and relate it back to the distance around the entire track. We took that equation and we resolved for y. So now, here's the big idea, okay? The y that we just found, this purple y, this like reddish purple, is the same thing as this y that's in the problem. It just looks a lot different now because we have other given information about it. Ultimately in the problem, what are we asked to do? What is the ultimate goal of the problem if we keep reading part D? Use a graphing utility to graph what? Area. Wait a minute, did we even talk about area yet? No, so now I'm going to ask you, they want you to talk about graphing the area of which specific part of the drawing? Which part of the room are they trying to maximize the area of? Look up here. The rectangular region, exactly right. So this orange region is what they're trying to maximize the area of. What is the formula for area of the rectangular region? Area is equal to length times width, or x times y, correct? Okay, so now this is where our function notation comes back into play. Area in terms of x is going to equal the x value that's already there times what is another definition of y that does not use the letter y. We found it earlier. This ugly thing down here, right? So I'm going to put that in. 200 minus 2x divided by pi. My area of the orange region in terms of x is equal to 200x minus 2x squared, all of which is divided by pi. Okay? That is going to be all of the different combinations of x and y. Think about this with our inputs. All of the different combinations of x and y that when we plug them in, ultimately gives me a distance around the track of 200. So pull out your calculator. You're going to go to y1, and you're going to plug that in. And since we think about the section that we're in, what shape should you get when you graph it? Probably a, what did we do in the first unit? It's all about parabolas. So you're going to have to zoom out. You're going to have to find the graph. Go ahead and plug it in. God bless you. Notation, make sure all of the numerator, the 200x minus 2x squared, is in parentheses in the top, divided by x. You're going to have to zoom out, maybe use zoom fit, suggestion. Because in standard window setting, you're not going to see much of it. Hopefully your room is bigger than 10 feet. Yeah. When you use zoom fit, did it give you the entire parabola? If it didn't, you need to go in and change the window yourself. Go in and look at window, see how big x is, keep making it bigger, make y bigger until you see the entire shape. A little common sense added in here. Again, when we put this in for y1 in the calculator, we need to make sure the numerator is offset. We can use parentheses in the denominator to divide. Getting close. Getting close. Go in and change it. Pick nice numbers. You don't have to put your decimal with the calculator, right? Play around with it a little. No, there's not really a shortcut, sorry to say. This is where copying off your neighbor is not a good idea on a test, because the odds of you getting the exact same thing are very slim. Anybody stuck? Can't do it? Okay, but go back to the window. Graph. See how you see the left side of it? Yeah. everybody has a parabola, correct? Okay, so in your parabola, this is what I want you to think about here, okay? When we do word problems, we're always going to be looking at a couple things. We're going to be looking at, in this example, the x value, the y value. What are each of the dots representative of? Each dot is the ultimate what? Look at the problem. Area. Okay? So area starts small, 0, 0. Obviously the area would be 0. And then it's going to get bigger and bigger and bigger and bigger and bigger. The goal here is to maximize the area. So what I'm really looking for is the point right here at the top of the mountain. How do we use the calculator to find that? Maximize. Go ahead in. Use maximize. All right, and what do we get for our maximum point in the calculator? Y'all should be pretty close. You might be off by a little bit of a decimal depending on your zoom in. What'd you get for your maximum? Go in. Because you're looking for the x. 501591. Let me see what you have there. 5159. Everybody get something close to like 49.999, somewhere in there? Yes? Okay, so to answer the question that they asked, what are the dimensions? Well, my x value should be 50. How do I figure out what my y value is? Because I didn't actually answer the question yet. I found x, but what's the dimensions of the rectangular part of the room? Yes, sir? I put 50 into which equation?
200 minus 2x
Over pi to get my y value?
Yeah.
This one down here? Here's my y value. Okay, so 200 minus 100 is 100 over pi. So y is going to equal 100 over pi. To maximize the area of the room.